This chart shows the total market capitalization of Taiwan compared to India. In early 2024, Taiwan's total stock market value overtook India's, reaching $4.95 trillion, despite India having a population 60 times larger. This shift is driven by one company, TSMC. As the race to develop artificial intelligence accelerates, investors have funneled capital into the only company capable of manufacturing the world's most advanced processors. The sheer volume of this industry is staggering. Every year, 1 trillion semiconductor devices are shipped, roughly 100 for every person on Earth, driving the industry toward $1 trillion in annual revenue by 2026. This microchip represents the world's most critical resource. These silicon circuits have become the foundational infrastructure for everything, from global telecommunications and energy grids to advanced military defense systems. This total reliance has forced a global realization. The physical foundation of the world economy now sits on a geopolitical fault line, with the entire supply chain concentrated in the hands of just 3 companies. The first link in this chain is NVIDIA. They serve as the industry's primary architects, maintaining dominance through their proprietary CUDA software, which ensures that modern AI models are built specifically to run on NVIDIA hardware. While NVIDIA designs the architecture, the machines required to build it come from ASML in the Netherlands. They are the only firm in the world with the technology to print these complex designs onto silicon. These machines use extreme ultraviolet, or EUV, lithography. Inside the system, high-power lasers strike tin droplets to generate unnatural light, while internal components accelerate at 20 Gs to maintain precision. This process is the only way to etch patterns just nanometers in size, features far too small for the human eye to detect, yet capable of routing the electricity that powers a neural network. These software designs and precision light sources require a physical forge capable of atomic-level mass production. Without a facility to turn blueprints into silicon, the technology remains purely theoretical. That facility is TSMC. Operating massive sites known as gigafabs, this single company manufactures over 90% of the world's most advanced semiconductors. TSMC controls a bottleneck called advanced packaging. Here, the core logic chip is stacked with memory modules to exchange data at high speeds. This creates a logistical hurdle. Chips manufactured in new U.S. facilities must be shipped back to Taiwan for final assembly. To address this, the U.S. government passed the CHIPS and Science Act, a $280 billion initiative. It includes $39 billion in direct subsidies to encourage companies to build and modernize fabrication plants on American soil. This has sparked a global cycle of intervention. The U.S. formed the Chip 4 Alliance with Taiwan, Japan, and South Korea, while China launched a $50 billion fund to achieve total domestic self-reliance. These policies mark a shift from global efficiency to strategic fragmentation. Governments are now prioritizing national security and domestic sovereignty over the traditional cost advantages of a centralized supply chain. Building this domestic ecosystem is proving difficult. New projects face years of environmental reviews and a severe shortage of the highly specialized technicians needed to operate these sterile environments. Replicating Taiwan's immense manufacturing efficiency takes decades of compounded experience. Even with billions in funding, a new facility cannot immediately match the yield and cost-effectiveness of an established gigafab. Because the world remains dependent on a single island, the geopolitical standoff over Taiwan represents an existential risk to the technology sector. A physical conflict would effectively freeze the global supply of advanced computing. This diagram illustrates the estimated fallout of a conflict. Economists predict a blockade or invasion of Taiwan would drain $10 trillion from the global economy, roughly 10% of global GDP. Control over this manufacturing process effectively dictates the pace of development for artificial general intelligence. The nation that manages the silicon supply chain gatekeeps the next generation of computing power. Ultimately, the balance of global power will be decided by these physical circuits. The future of AI will belong to whichever nation secures the hardware required to run it.